just wanted to go over this problem again real quickly. I don't want to take a lot of your time, but I just wanted to show you that there's two possibilities for this triangle. It is problem number 9, and it's on page 893. Probably ingrained in your memory from spending way too much time on this. Remember this triangle, there's two possibilities here, right? We have, it's a little 19-degree angle right over here. So it can come up 30 centimeters like this, and then come down about 25. Just I like to put centimeters after there to just keep straight. It's a linear, it's just a line, it's just a one-dimensional. It's not a square centimeter or anything like that. Okay, so our triangle can be formed like this, where this is A, this is B, and this is C. This is one possibility. Okay, now remember too what we're looking at here, and this is what we already talked about. This is side 1, this is side 2, and this is the angle 19 degrees. So we have here side, side, angle. And remember, if side 1 is less than side 2, we have two possibilities. Since you know we have two possibilities, you could go ahead and draw them out. But since you know we have two possibilities, it means that there has to be two different measures for the angle C. And because of that, this problem is actually just really straightforward. Let me just draw the other triangle for you so you can just intuitively see what I'm talking about here. But A is 19 degrees right over here, right, again. And the other option for A is it can come out 30 centimeters, just like we did up over here. So it looks exactly like the blue triangle, but instead of the 25 coming out, forming an obtuse angle with B, we can form an acute angle and come down about right here, and this is 25 centimeters right here. So I can come over here, let me just see, erase that little bit right there, and my triangle can be, this is A, let's do this correctly, this is A, this is B, and this is C. So you can see that C can be an acute triangle. Look out over here, C is a cute little triangle there, or C can be an obtuse triangle. And because you know that there are two possibilities, you can, in this case, just go ahead and use the law of sines like it says in the book, if you read the book. This is right. Perhaps that would be good sometimes to read the book. All right, so the sine of C over 30, the side opposite, has to equal the sine of A over the opposite of side 25. And so when we work this out, what we get here, when you work all of this out, you get the sine of A, right, is going to equal, oh, wait. Let's put this correct numbers in right over here. Since we know the sine of A, we know A is 19 degrees right over here, okay? So then what we can do here, let's work it out correctly. We could solve for C, right? The sine of C is going to be 30 times the sine of 19 degrees and over 25. So you could just see it's going to be that. Or C is going to equal the sine inverse, okay, of all of this, 30 times the sine of 19 degrees over 25. And when we do all of that, we find out, I believe we find out that C, when you solve for this, you get that C equals 22.7 or 23 degrees. Okay, so when we solve all this, we get that C equals 23 degrees. Let's go with 23 degrees. All right, that makes sense for this triangle right here. But remember with the sine function, and again, just pretty straightforward here, okay? The 23 degree right over here has exactly the same size, same sine. Sine is the height of the triangle, right? This is a 23 degree right over here. It has exactly the same sine as this triangle right over here. If we have the reference angle, this would still be 23, but remember the obtuse angle would be this one right here. See this angle right here. This one right here, off of here. That whole angle right here is the same as this little angle right over here. So we could just take the 180 minus the 23, and what do we get there? I forget. 180 minus the 23, and we get 157 degrees. So C, the two possibilities for C are going to be that C can be a 23 degree or it could be 157 degree. Okay, now Brescian, Sam, Carissa, and Ben, I felt like you guys were kind of tracking with me. Can you just, what we did was actually correct also, and what was throwing me off was I thought, oh, well, let's just do the general solution and kind of lead into the lesson for today. And it does work. It's actually that the problem is this is the ambiguous case. So let me show you what I'm talking about here. Remember, we solved this. We just, instead of solving it for angle C, we solved it for B right here, or I did. I solved this for the side B. And I did that, and remember when I solved it in class, I'm not going to redo it. I used the law of cosines, and I came up with side B here was about 52 centimeters, remember? And side B down over here was 5.5 centimeters down over here. We used the law of cosines to come up with that, and it worked, and that's true. In your book, they use the law of cosines when they have, in this ambiguous case where we have side, angle, they use the law of cosines. And so that's why I was thinking, oh, okay, that's what we need to do. Part of what it was, but also because I was trying to solve the whole equation, the whole triangle. All right, well, this is correct so far, but remember, again, B has two possibilities. B can be obtuse or B can be acute. So because of that, now I'm back to, I have this ambiguous case once again here. So if we're in this scenario right here, what I get when I use the law of sines, what I get here for angle B is 42 degrees. And see, that's not right. And that's what was throwing me off. When I use this case right here, I get that B is I think I get here that B is 4 degrees, something like that, 4 degrees, 4.6 degrees or 4 degrees. And that is correct, actually. 4 degrees works. If you take the 19, the 157, and the 4 degrees, it works. But up over here, see, this can't be 42 degrees. And the reason why, when you use the law of sines, B is 42 degrees. But remember now, again, the law of sines. Because it's the sine, once again, the sine is tricky. You got this 42 degree angle right over here. But remember, if it's an obtuse angle, I'm in the second quadrant. And so out over here, I can add the 42, you know, what do I get? 180 minus 42, I get 138 degrees. And so that's actually what B was supposed to be, 138 degrees. Because remember, the sine of 42 degrees is exactly the sine of 42 degrees equals, it is the same thing, the same height in the circle as the sine of 138 degrees. This is the problem with periodic functions. So since I had the two possibilities here, B could be 42 or 138, I'm going to pick the 138 because B is obtuse up here. And when I used 5.5 centimeters, when I did the law of sines with the 5.5 centimeters, I got 4 degrees up here for B, and that was my only choice. I'm in the first quadrant. B is an acute angle, and so I don't have to worry about my two choices in this second case right here. So here's like my first case, right? And here's my second case. All right, so hopefully that clarifies. I don't want to take any more of your time than that. That's enough. Thank you so much, everybody, for your time, and Lord bless you guys, and I will see you all in class on Thursday. Bye.